Hello, my name is Mr. Hare, and I would like to formally welcome you to physics this year. What you see in front of you is my primary means of communicating physics with you over the course of the year. We're going to be doing a lot of videos that take the place of me lecturing in class. So probably about twice a week, you're going to be here at some place, probably home or at school, someplace, and you're going to watch me lecture about the material, and then we're going to spend class time doing the homework. I like doing it this way. Number one, the research says that you learn better this way. Number two, when I got my master's in education, that was my thesis, is this a more effective way of learning physics? And it turns out students get better scores on tests having learned this way. So that's what we're going to do. You're going to see me here a couple times a week for 15 minutes at a crack explaining how things work. And you don't have to understand it. Don't get me wrong. As you watch these videos, if you don't get what I'm saying, that's okay. Because what we're going to do in class helps you understand that. We're just going to define terms and watch videos to show different phenomenon, and that's going to be the primary purpose of this. Whether or not you understand it, it doesn't matter. So don't panic if I explain something on a video and you don't understand it. You're not supposed to understand it here. It takes time. Let's talk a little bit about how you're graded, first of all. So what I did was I printed off a student from last year. I printed out a grade report from a random student from last year, and I just wanted to show you kind of what you're going to look for. So this is the entire of semester 2 that you're seeing here for a student. I've made them anonymous so you can't tell who they are. But the first thing you'll notice, they had an A. They had a 95.4%. You're going to be graded on 3 different things. Number one, the biggest thing that you're graded on is your tests. That's fully 60% of your grade is going to be your tests. 30% of your grade is going to be quizzes that we take in class. And the other 10% is going to be a small quiz that you take after every video. So tests, quizzes, and after you watch a video, there's like a short 3 or 4 question quiz that you take online. And that's what makes up your grade. Now, 40% of your full semester grade, 40% of it is one quarter, 40% of it is the next quarter, and 20% of it is going to be your semester exam. Now, there's some neat caveats within physics. I'm not a hoop jumping person. I don't believe that I should force you to go through hoops, and I don't like going through hoops that I don't need to. So here's kind of how this works. So you take a quiz, and let's say you don't do so well. You get a 7 out of 10 on it. You get a 70%. And then you go through the chapter. We usually have 2 or 3 quizzes every chapter until we get to the test. Learning physics is a messy business. It's not something people get on the first try. And I don't expect you to know it on the first try. I like to give you feedback, and that's what quizzes are. It's you taking some questions by yourself, and I give you feedback. If you get to the test, and let's say you get a 95 on the test, what I do is I go back and I replace every quiz that you took in that chapter with your test score, if your test score is better than that quiz. So that quiz that you got a 7 on now becomes a 9.5 because you got a 95. I believe that you've shown growth, you've learned the material, and I don't think that you should be punished for not knowing it at the beginning. Now, if you do worse on the test, let's say you got like a 65%, I'm going to leave that quiz the way it was, okay? And that's how the grading works. Now, on top of that, still, let's say you get an 85% on every single test, and then on the final exam, you get a 95%. I will give you an A in physics and 95% in physics if on the final exam you can show growth. If on the day of you can show me that you know everything, bam, that's it. So I believe that you should be able to fail, not fail like But you don't have to know everything right away. And a lot of people really panic at the beginning just with this whole process of, I don't know this right now. And it's okay to not know it right now. It's okay to not do well in the first couple of quizzes. You're still learning this material. It's not as easy as you might think. It is easy, but conceptually it's very difficult. So I want you to take heart. I don't want you to give up. This whole idea of watching a video, maybe this is the first time you've been in a class where you've watched videos for a lecture and then you come into class and do your homework. I believe it's a good system. I want you to believe it's a good system too, and I want you to buy into that system. So if you go home and I tell you, oh, watch the video for tomorrow, and you don't watch that video, you're going to be coming into class and I'm going to give like a worksheet or I'm going to ask questions and you're going to have no basis for your understanding. You're bucking the system, and it's going to be even worse for you. So I really need you to watch these videos. You don't need to understand them. You just need to watch them and take notes on them while we're going through it. Okay? So this is just so you can kind of see. Let me go now to the website. This is going to be my primary means of communication. Everything that I've got for physics class can be found here on the website. So the first thing you're going to notice, there's the title page. These are all of the chapters that we're going to go through throughout the year, and they're right in order, 1 through 22. I always put a fun video up here. Every time I cruise the internet and I find something fun, I put it here. They're really cute. This is a kid who plays with a leaf blower. It's a good demonstration of conservation of momentum. When something has mass and velocity that's being pushed this way, it exerts an equal and opposite force on you going this way, and this kid's too little. He doesn't understand. Good physics. The next thing that you're going to see over here is the calendar. I'd like you to embed this in calendar. If you have a smartphone, you can just embed this. I'll show you how to do this on the second day of class so that you can get all these feeds coming to your calendar. But I always show when things are due. So you can just look on this and it will tell you exactly when things are due. Physics Seal. I like to send out reminders to students. So we'll do this a second day of class also. I'll sign you up to get reminders. So if you forget, or maybe if your parents want to, or you didn't get it done the first day of class, these are instructions on how to do that. Let me just give you a tour of what's inside each of the chapters. Our book, we do have a book. You're not going to get a physical book, but the book is online. So if you want to know a little bit more about something I'm telling you, I don't maybe explain it to the best of what you think helps, you can always go to the book. I'm kind of going out of this book. Now this book is the teacher's manual too, so it's got all the answers to any questions that might be out there, but this is the book that we go through. Notes, when you watch a video, so here you'll see here's our first video that you're going to be watching right now. It's right here. There's notes that go along with that. So I'll pass you notes out. I'll print them out for you once. If you lose them or forget to get them, you can print them yourself. The notes are usually located up at the top, or I've got a link underneath each video that you can print them. Maybe you say to yourself, Mr. I don't have a printer. That's okay. You're going to have to do it the old-fashioned way. I get too many excuses from people. Oh, I didn't watch the video because I didn't take notes home. That's complete baloney. Watch the video, write down old-fashioned pencil and paper. I made flashcards. Every chapter there are some terms. I have Quizlets for every single chapter. You can click on these and you can practice with the flashcards that we have for each chapter, because there's going to be a lot of that on the tests. I have a study guide too. So in preparations for every test, because they're worth a lot, if you want to do a practice test, there's a study guide here and any worksheets that we're going to be doing. So this is kind of the typical layout for every chapter. And then you'll notice too, below each one it says bonus quiz. So this is the quiz that you take. That's that 10%. You'll click on this, you'll select which hour you have physics. And then it's just got a few quick questions about the videos. These questions are never going to be questions that are about understanding. They're always going to be questions that are right there. Like if you watch the video and you take notes, you should get 100%. And you can go back and rewatch the video. You can have the quiz open in one half of your screen as you're watching the video on the other half and just go. That's perfect. The only point to this quiz is that, are you watching the video? I like to keep a running tally. Are you watching the videos? You know, because parents come to me a lot of times, why is my student not doing so well? And the first place I go is, are they watching the videos? Because if they're not, they're basically skipping lecture. I mean, how do you know physics if you're skipping the lecture? I think that's about it for the website. And chapter 1 tour. How do you take notes? When you're going through these videos to watch them, what I want you to do is have a pencil and paper with you. Key up the video, be taking your notes as I'm speaking. This is going to take the place of me lecturing you inside of class. You've probably come from other classes where you're taking notes. This is your chance to take notes. We're just taking notes not with me in class. You're doing it virtually because I think our time is really best spent trying problems in class, and I can help you with your individual problems. So I'll be cruising around answering questions. I think that's your best use of my time and your time. When you're doing the problems, how often have you gone home with an assignment and you're like, I don't know how to do this? Like you sat through lecture, but you get to the problem and you have no idea. Wouldn't it be nice if the teacher was right there? That's the whole idea behind doing the homework in class with me and watching the lectures on video, is that you can have your specific questions about the content answered by me, okay? I have a YouTube channel if you're interested. If you go to YouTube and you type in Mr. Hare, I've got all sorts of fun videos. Every time I see a fun video that deals with physics, I save it. I'm a pretty big deal. I've got 286 subscribers right now. I just don't want to brag, but if you go to my playlists, I've organized them. It's really a repository for physics teachers. So I've organized them by like thermodynamics by chapter. So there's 72 videos that I have here dealing with thermodynamics, like melting silver using hydrogen. Can you put your hand in molten lead without it? The hottest place on Earth. How to make a paper airplane fly forever. Why do ice cubes crack in drinks? Slow motion. What do things look like in a thermal camera? A new microwave that's got a thermal camera built into it. What is Fahrenheit? How see-through engines. So these are just cool things that if you're interested in learning a little bit more, my YouTube channel is just chock full of really neat stuff that if you're into watching cool videos, these are, I think they're cool. That's me. And then lastly today, the last thing I want to finish up with, I do want to watch a video with you. This is my friend Derek Mueller. He is Australian. This kid was valedictorian of his high school class. He went on to get his PhD in physics education, and he started this website called Veritasium. Right now he's working with Bill Nye. He's one of Bill Nye's correspondents. I love his videos. He likes to address common misconceptions within physics specifically, and it's really great. All of his videos are awesome. I highly recommend that you guys check him out if you like this video right here. So let's watch it.
I'm going to give you guys three numbers, a three-number sequence, and I have a rule in mind that these three numbers obey. And I want you to try to figure out what that rule is. But the way that you can get information is by proposing your own set of three numbers to which I will say, yes, that follows my rule, or no, it doesn't follow my rule, and then you can propose what you think the rule is. Is that fair?
Yeah.
Yeah, okay, so here are the three numbers. 2, 4, 8.
2, 4, 8.
You don't need to continue the sequence. You can propose a totally different sequence, whatever you want to propose, and I will...
So what he's doing, he's trying to set up a small version of science with these people. Like here, you've got an observation in the universe, 2, 4, 8. Can you figure out what's going on? Can you conduct your own experiments to figure out the subtleties of the universe? And there's just it's so simple, but it's beautiful. 2, 4, 8. You observe something in nature. Oh, look it. Lightning. I wonder how that happens. So you make hypotheses and you conduct experiments to see if they verify. And this is, you'll love it.
We'll simply say yes or no. That follows my rule.
2, 4, 8. 16, 32.
16, 32, and
64.
those also.
So they've
follow
done an
the rule.
experiment, and
Okay.
the experiment
What's the
works.
rule? What do you think?
Multiply by 2.
That is not my rule.
What?
And there it
That's
is.
not my rule. But you're allowed, if you want, propose 3 other numbers.
3, 6, 12.
3, 6, 12.
3, 6, 12 follows my rule.
10, 20, 40.
10, 20, 40.
That follows the rule.
Yeah, I'm still multiplying by 2.
I know.
Ah.
I know what you're doing. And yes, it follows my rule, but no, it's not my rule.
5, 10,
10 and 20.
Follows my rule.
100,
200, 400.
Follows my rule.
500, 1,000, 2,000.
Follows my rule.
Want me to keep going?
But do I just keep going? You're going to tell me your rule?
Am I doing it the wrong way? Am I approaching this the wrong way?
You're totally fine,
Okay.
but you're approaching it the way most people approach it. Like, think strategically about this. You want
So they're doing experiments, and they continue to get answers, but they continue to not understand the universe. It's so perfect. I really love this.
information.
Yeah.
I have information. The point of the 3 numbers, right, is to allow you to figure out what the rule is.
Okay.
Okay, I'm going to give you the numbers that I don't think fits the sequence and then see what you say. So I'll say 2, 4, 7.
Fits my rule.
So whatever I propose is right?
So is your rule like you can propose any number?
So the rule is anything we say is yes.
No.
Damn it.
But you are on the right track now. Hit me with 3 numbers.
3, 6, 9.
Follows my rule.
Oh, that didn't follow my rule.
This is good, right?
5, 10, 15.
That follows my rule.
What? Oh. Really?
Yeah.
I don't believe this.
1, 2, 3.
1, 2, 3.
Follows the rule.
What about 7, 8, 9?
Follows. Yes, that follows the rule.
8, 16, 39.
Fits the rule.
Excellent.
But we're no closer to the rule. I want you to get to the rule. How about 1, 7, 13? Follows the rule.
What?
11, 12, 13.
How does this
Follows
make
the rule.
sense?
10,
I don't
9,
know how
8
to do this.
Does not follow the rule. 10, 9, 8 does not.
Oh, so is it all in ascending order?
Booyah.
Okay.
Up top. Yes, first
that
ones
what it
to get
is?
it. You guys nailed it. That's the rule. That's
always-
the rule. Increase numbers in increasing order.
Aw.
Numbers in ascending order. 1, 2, 3, 4, 5, 6, 10, 15, 25. Doesn't matter. Any numbers in ascending order. I was inspired to make this video by
Albert Einstein has a quote that says, "God is subtle, but he is not malicious." A lot of people have modified this quote to say that nature is subtle, but not malicious. When you step back, you see how simple the universe really was. When you saw the numbers 2, 4, 8, you think, oh, they're multiplying by 2. So you continue to do experiments being verified by that. But that's really not the way the universe works. The universe works, it was even simpler than that. But it was very, very difficult for these people to get to that understanding. And that's science, my friends. We're trying to get to the root of how the universe works. All of us in science, that is our goal. That is our main primary objective. How does the universe really work? And only by doing experiments can we do that. And you reject, if your experiment tells you something is wrong, then you reject that way of thinking completely because it's not correct. You've just proved yourself wrong. So he's going to talk a little bit more about this.
the book The Black Swan by Nassim Taleb. Now, the black swan is a metaphor for the unknown and the unexpected. I mean, in the old world, the theory was that all swans were white. So each instance of a white swan would make you think, yeah, that theory's pretty good. But the point is, you can never prove a theory true. And in fact, when people found Australia, they realized that there were black swans. What was interesting for me was that everyone I spoke to came up with a rule very early on and then only proposed numbers that fit with that rule they were thinking. I was looking for you guys to propose a set of numbers that didn't follow your rule
Right.
and didn't follow my rule. I was looking for you guys not to try to confirm what you believe. You're always asking something where you expect the answer to be yes, right? Like you're trying to get at it.
But instead you want to get the no.
You want to get the no because that's much more informational for you than the yes. Like if everything's
No, that
giving a
is
yes.
true. That is really true once you say that.
That is what's so important about the scientific method. We set out to disprove our theories. And it's when we can't disprove them that we say, this must be getting at something really true about our reality. So I think we should do that in all aspects of our lives. If you think that something is true, you should try as hard as you can to disprove it. Only then can you really get at the truth and not fool yourself.
And that's it. I mean, you guys are coming out of chemistry, and the whole idea of the Bohr model of the atom, where we have a central dense nucleus, the whole reason that that came about was, they were the gold foil experiment where they're firing, I think, protons at a gold leaf, and the principal investigator, he came around the corner and he was having his undergraduates do the experiment. They were the ones actually doing the experiment. He was eating a sandwich and he stuck his head in and he said, "Hey, look to see if some of the alpha particles bounce off. Look for the disproof." They turned their detectors on the other side of the gold foil, and lo and behold, 3 out of every million or so would bounce off. And they weren't expecting this. And that revolutionized the way that we think about the universe. So continue to ask yourself, try to disprove things. Like, always question everything, because that's the true nature of science. This video is longer than they normally are. I'm a little bit long-winded just because I wanted to get you introduced to physics, and I apologize. It's exciting for me. I want you to leave this video just knowing a couple of things. That number one, physics is fun. I love physics. Number two, I want you to do well. Like, I am here to do my best to get you where you want to go. Number three, physics is difficult. It's conceptually difficult. It's not so much math hard. We're only going to be multiplying, adding, subtracting, dividing. It's very simple math. But when do you add? When do you subtract? When do you multiply? When do you divide? That's the real tricky part. Be patient with your understanding. Don't put goals on yourself that are going to make you feel like a failure. I have my biggest issues are people who come into my classroom and say, "I need to get an A." I want you to get away from that thinking as far as you can. Enjoy the process. Do the best that you can. I just for giggles, what I did is these are the final grades. So if you're wondering, like, how I've heard physics is pretty hard. This was last year's physics final grades. So I had 17 students that were A's. I have 23 who were B. I had 9 that were C's, and I had 5 that were D's. Fully 70, I think like 75% of my students get A's or B's. I really think if you work, that you can be one of these people. I think that the people who are in the D range, they're people who give up, who on their first test or something, they take a punch and then they're quick to give up. Don't give up. I think the C people, they're working, but I think if they worked a little bit harder, they could very easily get in that B range. If you leave with one last thing, I don't want you to ever give up. You're going to take some hits here because this is conceptually difficult material, and I don't want you to, your first reaction to be to give up. Continue to stay with it. Continue to ask me questions, and I want you to rise above the adversity. I can make physics really simple. I could make it really easy, but I would be doing you such a disservice when you get to college because it would murder you. I could make it really hard, and it wouldn't be any fun, and nobody would take physics. So I try to walk the middle of the line between making it too easy and then you're not prepared for college, and too hard where none of you find success. So I feel like I'm doing an okay job, and I continually print these graphs after every test to just make sure that I'm doing okay. I really want feedback from you. If you're having a hard time, come and talk to me. I want to help you. I really do. I enjoy working with students, and I look forward to a really great year. Thanks for putting up with me for these 25 minutes, and I look forward to many more meetings just like this.